Hello and welcome to the 7th lecture of this Python from Scratch course. In this lesson we're going to learn about classes and objects inside of Python, which is another level of abstraction following nicely from functions, allowing us to group relevant pieces of information in a nicely defined space from where we can reuse them. So let's have a look at how we define our class. Then let's have a look how we create instances of it using objects, and then let's dive deeper into how we can utilize them fully to achieve our goals. So the way we define classes in Python is using the class keyword, similar to the way we did with functions using def keyword, followed by the name of our class, again similar to functions. In this case, we're gonna call our class my class, obviously because it's not doing anything particularly useful just yet, so we don't have a proper name for it. Then double dot, and inside of it, followed with an indent, as you remember, there's all the information that's going to be stored inside of our class. First, we store a bunch of variables. There can be as many variables as you want, and they can be any type. So now we just have two examples, one variable of type string, in which we store hello, and one variable of type int, in which we store 14. And the second thing we can store inside of our classes are methods. Methods are basically functions, but the only difference between the function and the method is function is a standalone piece of code that doesn't belong to anywhere, to anything, while methods belong to a class and can only be executed through that class. So that's pretty much the only distinction. There is some discrepancy between different programming languages, but that's how we're going to be referring to this in this course. So as you can see, one simple method is defined using the def keyword, similar to functions. Then we write the name of our method. It's called class method. And we pass a self argument to it. We're going to come back to what the self argument is in a few minutes. But everything else works exactly like in a function. When this method is called, this code will execute. So that's how we define our most basic class. And what a class is basically a blueprint for some data. By itself, it doesn't do anything. So if we were to comment out these lines of code and run our program, nothing would happen. We wouldn't see anything because we just created a blueprint of our class and we didn't do anything with it. So in order to use our class, we have to create instances of these blueprints. So the way I like to think about it is imagine a building blueprint. An engineer, an architect designs a building plan on a piece of paper, and then they give it to an engineer. And what an engineer does is they create an actual building from that blueprint. The way we do that in Python is as follows. We create a variable, we are going to call it myObject for now, and we're going to create an instance of our class. And an instance of a class is referred to as object in Python. So what this does is now inside of my object variable, we have an instance of everything we have defined in our blueprint of our class. And now we can use it. We can use it as follows. We can use methods using the dot notation. My object.class method will call a class method we defined. And if we run our code right now, this line is going to be printed. Hello, I'm printed from inside the class method, which is this line of code. So line 14 calls a class method inside our class, which was defined right here, and this line of code was executed. We can not only access methods, but we can also access the data inside of our class. So for example, the word and the number. If we try to access number, we would get 14. So that's exactly what's stored here. If we were to change it to 16, run it again, we would get 16. And we can also get the word. Hello, so that's exactly what's stored here. So following on from this comparison of a class to a blueprint, you can have many different buildings built from the same blueprint, and the same way you can create many different objects from the same class. So for example, my object 2 is also equals my class. So now we have created two different objects, two different instances of our class, my object and my object 2. And if we were to call the same method, it will execute exactly the same, because that's how the method is defined. But the difference between different instances of an object is we can manipulate the data inside of those without affecting each other. So for example, if we wanted to change what is stored in the number variable inside my object, we would just do my object.number equals 18. And if we were to print it, it would print 18. But now if we were to print a number stored inside my object 2, (18 and 16). So 18 is printed from this line. It prints a number stored inside my object, which we changed to 18. But when we try to print a number stored in my object 2, it prints 16, because it was just initialized to 16 initially, and we never really changed it. So each instance of an object, each instance of a class, while it follows the same blueprint, it is really a unique piece of data, and it doesn't affect one another directly unless we specify for it to do so. So now that we know how to define basic classes and we know how to create instances of them using initializers, and we know how to access methods and the data in them, let's go deeper inside how we can define more complex classes. I said I will come back to the self keyword, and I'll explain what it does now. So another difference between methods and functions is functions can take from 0 to however many arguments you want to give it. But the methods which are attached to classes have to take a self argument, which is automatically given to them. And what a self argument is basically, it allows us to access the data of our class inside our method. As you know, by definition, the only information, the only data we can access inside our functions is the data we either pass to it or the data that's created already inside the function. Any data outside of it will not be accessible from inside the function. So if we try to do print word, let's uncomment everything here so that doesn't bother us. So we're literally going to create our class and we're going to call this method. And let's run our code. We will get an error saying that the word is not defined on this line. So we are trying to access word which is defined here, but it is not accessible from within our method. And that's where the self argument comes in. What the self argument allows us to do is access all the other data that's present in our class. And we use it, we access it using the dot notation again. So if we were to run this, we would get hello. So self.word is a reference to the word variable inside of our class. And obviously, just like with any other functions, we can give more arguments to it. Temp. So we can give additional argument, and we can pass that argument when we call this method. And let's print it just to make sure it works. Yeah, so it printed hello and 20. So it printed hello, which is stored in here, and it printed 20, which was an argument passed to it during a method call. So those are the two types of information we can store in classes, variables of any kind and methods. And there is actually another very special method that we can define for our classes, and that is called a constructor method. And I will show it now. So def init looks like any other method. It is defined exactly like any other method, and the code is written exactly like it. But it's special in a way that it will be called every time you're gonna try to create an instance of your class. So by definition, we created an instance of our class like this without an init method because we didn't define it. But if we wanted something to happen every time an instance was created, for example, printing an instance was created, This piece of code is going to be executed every time a new instance of our class is created. And if we uncomment this line and create another instance of our class, we will get it printed twice because this constructor method was called twice. Usually what constructor methods are used for is to initialize our object and to store the relevant important information. So for example, if we wanted to override these two values, we could take some arguments, word and number, and we could overwrite self.word equals word and self.number equals number. So what we are doing is we are overwriting this variable with the variable that got passed to us through the method call, and we are overwriting number as well in the same manner. So now, if we try to run our code, we will get an error because we are trying to we're trying to create an instance of our class, but we don't pass it all the necessary arguments in order for it to be constructed. So what we actually need to do is we need to pass it the word apple. It can be any word, and some number. Let's do 25. And now our code executes without problems. And now just to make sure that our constructor method executed as we expected, let's actually print the values. My object.word and my object.number. So as you can see, we got printed apple and 25, not the hello and 16 that were originally defined in our class. That's because during the construction of our class, we passed two new variables, apple and 25, which were received in our constructor method, and which were then used to override the variables we had originally defined in our class. So that's usually the use case for our constructor method. And that is everything you need to know about classes for the time being. We will have a look at a real life example of a class in just a moment, but you might be questioning yourself right now, why do we need classes? Why do we need this level of abstraction? And the answer is really simple, really. We could write everything we have written in the class just linearly, line by line, starting at line 1 and finish at line 10,000, 100,000, depending on how long your code is. But as the same way as with functions, classes allow us a different level of allow us to write our code in a modular fashion, which allows us to group relevant pieces of information in the same place, and they can be accessible very easily. We know exactly where to go to look for our information, and we know exactly what methods are defined to process that information. And it is all stored nicely in a readable manner and can be reused for as big problems as we want. Now let's have a go at a real class. So I'm just gonna delete all of this, and I'm gonna rewrite the class we currently have. So let's think of a scenario where we want to create a class which stores information about a person. So we are naturally gonna call that class a person, and we want to store the following information about them. We want to store their name, and by definition it will be empty name, for example, by default. We will want to store their age, which is by default 0, and let's say height, which is also by default is 0. Now, in our constructor method, we will want to actually overwrite all of these values, and let's change them. Height, name, age, name, so now every time a constructor method is going to be called, we're going to overwrite these values with the values passed to us through the constructor method. And let's create a semi-decent, semi-useful method for our class. Def increase age, self.age plus equals 1. So we have defined a person class, which stores 3 data points about the person, their names, their age, and their height. We have defined a constructor class, which is going to be used to overwrite the data and store some real data about a person. And we have a very simple method that's going to increment their age by 1. Now let's see that in action. Person1 equals person Nick, who's 25 years old and whose height is 175. And let's make sure it was all stored safely. It was all stored correctly. Print person1 dot name, person1 dot age, person1 dot height. And let's run our code. And what we have printed is Nick 25, 175. So now we know that all the information we passed was stored correctly in these variables. And now, just to make sure our class is working as expected, let's create a different instance of our class, person2, person Joanna, who's 23 years old and who's 180 centimeters tall. And we're gonna print all the information about them just to make sure it is stored correctly again. Nick 25, 175, Joanna 23, 180. So we know that we have created 2 instances of our person class, stored in person1 object, person2 object, and we know that all the data was stored correctly. Now let's actually try to use our method. So we have defined the person1 age to be 25, but before we actually print age, let's increment it. Person1 dot increase age, and we call it, and now Nick is printed Nick 26, 175. So even though we supplied 25 during the construction of our object, before we printed the age, we actually called the method inside our class, which increments the age of the person by 1, and therefore 26 was printed. Again, as I was saying earlier, one instance of a class, one object doesn't affect the other. So as we can see, Joanna's information is completely unaffected. And that's a very simple example of how this can be used. So obviously, in a real life scenario, we would have much more information about person. We would have their place of birth, or their parents' names, or their date of birth, and so on and so forth. And we can store as much information about the person as we need it, depending on the application of our situation. And then we could have as many methods as we would like. Maybe we want to increase an age. Maybe we want to calculate an age of a person if we don't know their age and we only know their birthday. Maybe we want to check if the person was born before a certain date. Maybe we want to check whether the person's name starts with a certain letter, and so on and so forth. So a real life example of where this would be useful would be in a database if we want to store information about different people, and we would want to know that each person has certain fields filled out. We could use this kind of approach. But obviously the possibilities are endless. It doesn't have to be a person. The class can be anything. The power of a class is that we can define any variables to be stored in it, as well as any methods to be defined inside of it. It can be vehicles, it can be houses, it can be people, it can be food, it can be literally anything. And that allows us to create modular programs which are very easy to reuse. Now that we have all the information in the same place, it is very easy to read. We know that all the information regarding this particular person is going to be stored in this place, and we're going to know exactly what we can do with it. And that's why classes are so powerful in Python. Anyways, that's all I wanted to talk to you about today. I hope you enjoyed it, and I'll see you next time.